We have studied about energy for a system of point charges, but there's no point charge in the real world. Each point charge actually is a charge that distributed in one area. In general, we'll write it in terms of volume charge density. If the charge is very thin, we can consider it as a surface charge. So we write it as a surface charge density. If the charge is distributed along a wire and the cross-section of the wire is small compared to the length of the wire, we can consider it as a line charge density. We can consider each point charge as the density multiplied with its unit. For example, so we can multiply the volume charge density with the volume dV. We can consider this as the point charge. We have a cloud of charge with its volume charge density of rho sub v. In short, we can call it rho v. If we divide this charge into a small pieces like this, and assuming that each piece is very small, we can approximate it as point charge. Each piece called dq is rho v multiplied with a small volume of dv. We call it dqi. We could compute potential V produced by all charge. We call it Vi. We can obtain energy using equation from previous class by replacing Qi with dqi and summing all dqi, Vi together. dV is very small. The volume approaches to zero. Then the charge dq also approaches 0 coulomb, and we would have infinity pieces or infinity point charges. This summation equation would change to the integral equations because n charges, n changes to infinity and dq approaches 0. Then the summation sign needs to change to integral sign. Since dq approaches 0, actually it is 0 at one point. It needs to be computed in a small volume dV. Then the cell energy of each point charge is 0, or each dq has 0 energy. Let's consider if we have two point charges of 1 coulomb, 1 meter apart. Since q1 equals to q2, then v12 is the same as v21, which is this. The energy computed using previous class would be like this, which is about 9 gigajoule. It would light up a 100 watt bulb for almost 3 years. This does not include energy for each point charge, because it would be infinite joule. Let's zoom in very close to the point charge. Actually, it's not only at one point. Assume that point charge actually is a cloud of charge which uniformly distributed as a sphere which has its radius of 1 micrometer. Then the volume charge density would be charge 1 coulomb divided by the volume of a sphere. We could obtain energy of this charge with the equation I just discussed. It will be in the next example.